Hello students, this is Aileen Sonia, Assistant Professor in RMD Engineering College. From the subject Basic Electrical, Electronics and Measurement Engineering, I am going to take from Unit 5, which deals about electrical measurement. These are the syllabus topics of Unit 5. So the topics are characteristics of measurement, errors in measurement, taught in indicating instruments. So under that, about the instruments, you'll be studying about moving coil and moving iron meters, energy meter and watt meter. For these instruments, you will be studying about its working principle and the torque equation. Then you'll be studying about transducers. So transducer, under that you will be studying about the classification of transducers, the various classification of transducers, and about some transducers we will be studying like thermoelectric transducer, RTD, strain gauge, LVDT, LDR and piezoelectric transducer. The last topic will be oscilloscope. Under that you will be studying about cathode ray oscilloscope. So here in this video we will be studying about the basics of the measurement and we will be studying about errors in measurement. So generally the classification of instruments is based on mechanical, electrical and electronic instruments. So mechanical instruments. Mechanical instruments are very reliable for static and stable condition, but they suffer from a very major disadvantage because they are unable to respond rapidly to measurements of dynamic and transient condition. This is due to the fact that these instruments have moving parts that are rigid, heavy and bulky and consequently have a large mass. So here mechanical instruments, as you know, vernier caliper. So vernier caliper you can say as an example for mechanical instruments that you are using for measurement. So electrical instruments. So when you are passing current, the output deflection. So directly, so due to the passage of current, you are able to measure the output of the quantity that you need to measure. So this instrument comes under electrical instrument. So what is the difference between electrical and electronic instrument? So if you use a semiconductor device, it comes under electronic instrument. So the advantages of an electronic instruments will be higher sensitivity, fast response, a greater flexibility, lower weight, lower power consumption, a higher degree of reliability than their mechanical or purely electrical counterparts. So next, classification of instruments. So there are three classification of instruments, three various types of classification. So first classification is based on absolute and secondary instrument. So what is absolute instrument and secondary instrument? So absolute instrument gives the magnitude of the quantity under measurement in terms of physical constant of the instrument. So example for absolute instrument is tangent galvanometer. As you know, tangent galvanometer, you can measure current by the deflection. So you might be remembering current is measured I equal to K tan theta. So based on that tangent of the deflection angle, that is in terms of physical constant, we are measuring the unknown quantity, that is the current, in terms of physical constant. So that's why tangent galvanometer comes under absolute instrument. Secondary instruments. So directly, so are those instruments whose output is measured to give the value of the quantity. So example for this is voltmeter. So voltmeter is an instrument to measure voltage. So directly the pointer will be pointing the value. So you can directly note down the value of the voltage. whereas in absolute instrument, that is in tangent galvanometer, by the tangent deflection, we will be measuring the current. Next classification is direct measuring and comparison instrument. So direct measuring is nothing but unknown quantity directly. If you're knowing by using the meter, if you're knowing the value, means it is direct measurement. Comparison is an unknown quantity. If you're comparing it with a standard, means it is comparison instrument. So example for this type of instrument is resistant measuring bridges. So as you know, in bridges, the unknown quantity you will be comparing with the standard, then from that by comparison you will get the value of the unknown quantity. The next classification of instrument will be analog and digital instruments. From the figure we can know what is an analog instrument and digital instrument. So digital instrument output will be in discrete steps or in terms of finite number of values, whereas an analog instrument will be providing an output which will be varying continuously as the quantity under measurement changes. So next classification is based on function. So based on function, there are three types: indicating function, recording function, and controlling function. So based on indicating function, so example is ammeter pointer deflection. So ammeter pointer deflection, so there is a pointer deflection, so from that we will know the unknown value. So from ammeter we will know the current value by the pointer deflection. Recording instrument. So recording instrument means, say for example seismograph. So seismograph, it will be measuring the earthquake the level by a strip chart recorder. So it will be recording the earthquake in a strip chart recorder. So that instrument comes under recording instrument. Controlling instrument. So for this example is carburetor or fuel injection system. So this is used in cars. So what it does, it measures the fuel requirement of the engine for different loads, speeds and accelerator pedal positions. So and accordingly it will be supplying the air and fuel to the engine based on the load, speed and accelerator pedal position. So this comes under controlling instruments. Next topic is errors in measurement. As this unit deals about electrical measurement about the instruments, we are studying this topic. So errors is nothing but, so definitely when we are reading the instruments, when we are taking readings, there is a chance of making an error. So what are the various types of error that we will be seeing in this topic? So generally there are three errors. So generally errors are classified into three types: gross error, systematic errors and random errors. So when you're studying this topic, so first you have to write about the cause. Then you have to write about how you can avoid it. So these 2 points should be there when you're explaining about each type of error. So for gross error, the cause for gross error is nothing but human mistake. So when you're seeing the instrument reading, you are by mistake, for example, the instrument will be pointing at 25.8 degrees Celsius. We will be seeing it 25.8, but when we are recording, you will be recording it as 28.5. So that is an example for a gross error. So cause is human mistake, due to human mistake in reading the instrument and recording, and thereby in calculation also definitely it results in error. So what are the various ways to avoid it or eliminate it? So complete elimination is not possible, but at least we can try to reduce. So what are the ways? So one is by taking great care in reading and recording the data, and the other way is by taking 2, 3 or even more readings should be taken. So when you are taking 2 or 3 times, we can cross check whether the reading what we have taken is type of error is systematic error. Under this error, we have 3 types of errors: instrumental errors, environmental error, and observational errors. So first, instrumental error. What are the reasons? 3 reasons are there. So one is due to inherent shortcomings in the instrument. Second is due to misuse of the instrument, and third is due to loading effects of instrument. So first reason, due to inherent shortcomings in the instrument. So inherent, what is the meaning of inherent? So inherent, you can say it as inborn. So when you're that means, so when you're manufacturing the instrument, so manufacturing defect. So when manufacturing itself, there is some defect in the instrument, and because of that, you will be having a error. So that you can say it as inherent shortcomings in the instrument. So how you can avoid inherent shortcomings in the instrument? So one is by substitution methods or calibration against standards, and second is by applying correction factors, and third is by again recalibrating it. So next, misuse of instrument. So the second reason for systematic error is instrumental error is misuse of instruments. So misuse is nothing but if we are not adjusting the zero of instruments. Say for example, when you are doing experiments, sometimes the pointer will be pointing above 0 or below 0. It will not be pointing correctly at 0. If it is not pointing correctly and at 0, and if you are not adjusting it to 0 and taking the reading, it will show an error. It will lead to error in the reading of what we have taken. So that is an example for misuse of instrument. So that is one of the reasons. The other reasons can be using leads of too high resistance. The third one is loading effects. So if we are loading the instructions itself, they would have given, but other than the max, if you are loading the instrument more than the maximum limits, it will lead to error in the measurement. Second error in the systematic is environmental error. From the name itself, you can understand. So due to environmental conditions like temperature, pressure, humidity, dust, vibrations, or external magnetic electrostatic fields, if there is error, it is called as environmental errors. So we have mentioned all these errors. So because of this, how you can reduce this environmental errors? So temperature, you can, because of the temperature, if you are getting error, you can reduce it by keeping the equipment in a temperature controlled enclosure. Next, a way to eliminate reduce this environmental error is by using equipment which is immune to these effects. For example, variation resistance with temperature can be minimized by using resistance materials and which have a very low resistance temperature coefficient. The third and fourth way is by employing techniques which eliminate the effects of these disturbances. For example, the effect of humidity, dust, etc. can be entirely eliminated by hermetically sealing the equipment. Then another environmental effect is if due to the external magnetic or electrostatic field their reading is affected, means we can provide magnetic or electrostatic shields. The last error, so in systematic error, is observational error. When you're reading the instrument, if you're reading if you're not standing in the correct position, means it leads to observational error. You would have heard of the term parallax error. To say So other name for observational error, we can also say it as Salix error. So from the figure, you can see that if you view at the correct straight angle, you can take the reading correctly as 250. Else, if you're standing left of the pointer, you may take it as less than 250, or if you're standing to the right of the pointer, you may take it as more than the actual value. So this error is called as observational error. The last error is nothing but random, or also called as residual error. So all these errors we have seen. So other than that, if you have error, means it is called as random or residual errors. So due to random reasons, any reasons, or residual means due to some unknown causes or many unknown causes all lumped up together. So it is called as random or residual errors.